Chapter 5. Saving time and memory. Sometimes there are valid reasons for not pushing our code up to the maximum limit. For example, sometimes to achieve a negligible improvement, we have to sacrifice on readability or maintainability. Does it make any sense to have a web page served in 1 second with unreadable, complicated code? We can serve it in a 1.05 seconds with readable, clean code? No, it makes no sense. On the other hand, sometimes it's perfectly reasonable to try to shave off a millisecond from a function, especially when the function is meant to be called thousands of times. Every millisecond you save there means 1 second saved per thousand of code, and this could be meaningful for your application. In this chapter, we are going to cover the following: the map, zip, and filter functions, comprehensions, and generators. Map. Map, according to the official Python documentation, map function iterable returns an iterator that applies function to every type of iterable yielding the result. If additional iterable arguments are passed, function must take that many arguments and is applied to the item from all iterables in parallel. With multiple iterables, the iterator stops when the shortest iterable is exhausted. So let's create a new file called map.example.py example, and there I wanna say list map list map I wanna say a lambda inside. I wanna capture a value with a variable called a, and then as a second parameter we're gonna say range, like this, a range of 3. Okay, let's print this and see what is returning. So Python chapter 5 and then map. Okay, and you will see that it's just iterating the range, its value 0, 1, and 2. In this case, we just have one iterable. But what about if we create another one called like this, and we pass a second as a third parameter ABC, like this? Okay, let's comment the previous script like this, and let's execute it again. Okay, and you will see something like okay, you will see better now. Now it's returning index 0 with the letter A, 1, B, 2, C. In this case, we've got 2 iterables, and so on. If you wanna add another iterable, you can add it like this. For example, let's comment this one and let's try another one. As a 4 parameter, I wanna say range from 4 to 7. Okay, let's execute it again. We've got an error because this one is inside the math function. Okay, inside this parenthesis, like this. Let's try again. I will see that now it's printing as a third item 4, 5, and 6. okay, in each item, of course. Probably you say, Frank, what about if I say something like this and I wanna print, okay, let's borrow this, delete this one, and say I wanna print a range of 2, but I wanna give it to 3 characters like this. Yeah, let's see, okay? You will see that the first parameter, well, the second parameter in this lamp function, it is the shortest, so it has more privilege over the rest of parameters. That's the reason that we've got here 0 and 1, A, B, okay? The same way, if you try something like this, something like, okay, when I say range of 4, okay, but you say only one ABC, and you try this one, you obtain something like ABC, because it's the shortest way. In this occasion, ABC, I mean the third parameter in map, has the privilege over the rest of parameters. You can also notice how the elements of each iterable are applied to the function. At first, the first parameter, the first element of each iterable, then the second one of each iterable, and so on. Notice also the map stops when the shortest of the iterables we call it is exhausted. This is actually a very nice behavior. It doesn't force us to level all the iterables to a common length, and it doesn't break if they aren't all the same length. Map is very useful when you have to apply the same function to one or more collection of objects. As more interesting example, let's see the decorate, sort, and decorate idioms, also known as Shortian transform. It's a technique that was extremely popular when Python sorting wasn't providing key functions, and therefore is less used today. But it's a cool trick that still comes in handy once in a while. Okay, for that I'm gonna create a new file called decorate dot sort dot undecorate dot file. Okay, remember that after the sorting we revert the decorate object to get the original ones from them. This is called the undecorate. So I wanna say students equal to dict ID 1, ID 0, credits, and dict math 9, v6, 6, history 7. Okay. Then the same way I want to create three more with its respective ID 1, 2, 2, and 3 formats. It's this one will obtain 6, this one A, and this 9 5. In physics, well, 7, 9, and 5. What about this one? 10, 10, very genius, and 7. Okay, that's the way. Oh, sorry, it's missing a parenthesis here. Now I'm gonna define a function called decorate student. Okay, return assume a student credits dot values, like this. Okay, and of course in a student. So I'm gonna return the student and also the sum of its credits. Decorate. Okay. In the other hand, I want to define another function called undecorate, which will obtain as a parameter a decorated student. Return decorate student dot one. Okay, now I wanna say a student equal to sorted map decorate comma students and reverse true. Then students equal to list map undecorate comma students, like this one. Okay, so let's execute it. Print students. Okay, and let's try again. When I say Python, in this case is decorate. Okay, just execute it. What have we got here? So we've got this one, but I don't like how it's physics here. Just correct it like this. Okay, let's execute it again. It doesn't result, but let's print first this. Okay, what are we obtaining here at this level? So we've got here we've got the sum of its credits by each item in this list. Okay, in the first one we've obtained 27, then 23, then 22, and as the first parameter, as the first item. In the second item we got the entire student. According with this, we're executing the second function, which is undecorate, which is obtaining just the index. Okay, which is obtaining the student, which is in the second index, or I mean the index 1, the second item, in order to undecorate to the original students list. One thing to notice about the sorting part: what if two or more students share the same total sum? The sorting algorithm will then proceed to sort the tuples by comparing the students object with other. It doesn't make any sense, and in more complex cases could lead to unpredictable results or even errors. If you want to be sure to avoid this issue, one simple solution is to create a 3-tuple instead of 2 tuples, having the sum of credits in the first position, the position of the student object in the students list in the second one, and the student's object itself in the third one. This way, if the sums of credits is the same, the tuples will be sorted against the position, which will always be different, and therefore enough to result the sorting between any pairs of tuples.